Hello, and also welcome back to lesson 4.5. Yes, very good. Jumpstart. We're just going to go through this real fast. For each of the following polygons, pick one vertex. Ding, 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 ding. And draw all the possible diagonals of the polygon that include that vertex. Well, there's no diagonals here because those are sides. So 0, 1, 2, 3. What conjecture might you make about the relationship between the number of diagonals drawn from a vertex and the number of sides of the polygon? Can you explain why this is so? Well, this was 3 sides, 0 diagonals. 4 corners. Is it sides or corners? Yeah, 4 sides, 1 diagonal. 5 sides, 2 diagonals. 6 sides, 3 diagonals. Sides, diagonals. 3, 4, 5, 6. 0, 1, 2, 3. 3 minus 0, or 3 minus 3, 4 minus 3, 5 minus 3, 6 minus 3, n minus 3, where n is the number of sides. Now that's not a conjecture, that's just a statement. Let me make it a conjecture. The number of diagonals in a polygon, let's use the word emanating, which means coming out of, emanating from one vertex is n minus 3, where n is the number of sides. That's my conjecture. Unproven, but supported. Practice using geometric reasoning in computational work. Yay. How do I look for structure in a diagram so I can use familiar features of the diagram to find the measures of unknown sides and angles? What measurements do I need to calculate first in order to calculate additional measurements? In the diagram, lines P, Q, R, and S are parallel. What diagram? There's no diagram. Oh, it's on the next page. Find the measures of all missing sides and angles by using geometric reasoning, not rulers and protractors. Who uses protractors? I haven't even given you protractors. Some of you have them. If you think you can't find, you should be able to find all measurements. But if you can't find one, say, well, I would be able to find it if I knew this, this, or this. Okay. No rulers or protractors. P, Q, R, and S are all parallel. So let's put this in. I like double chevron. It's more fancy. Okay, so right away we see some things like corresponding, 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 corresponding. Why does that look like a B? 50B degrees. Ooh. Supplementary linear pair. Remember this? 127, I believe. Hope I'm not wrong. Angles along a line add up to 180. So that gives you some more. You can figure out this one from that one. The vertical with some vertical angles. Yeah, this is 53 degrees too. Wow, we're getting them all real quick. Corresponding, corresponding, corresponding. linear pair, that's a right triangle. Now you can use Pythagoras to figure out this length, because remember you're supposed to try to find lengths as well. Let's see, linear pair. Opposite and okay. Here's two parallel lines cut by this transversal. Same side interior supplemental. I'll call this. This is the last one I'm going to do, and then I'm going to have you and Mr. Mazeppa work on it. I'm going to call this angle A. We know these add up to 90 because same side interior supplemental. 90, or sorry, they add up to 180. 90 plus A equals 180 minus 90 minus 90. A equals 90. Doing some algebra there. Quadrilaterals add up to 160, or sorry, 360. And I'm zooming the wrong way. Come on. 90 plus 90 plus 90 plus x equals 360. This is the x. Let's do some algebra. Combine like terms. Subtract. Oh, it's also a 90. X is also 90. So now we know this is a rectangle. And what do we know about rectangles? Opposite sides are congruent. So that means they're the same. So this is a 12. That's an 18. All right, I'm gonna stop there. I think you guys can get the rest of them. Yeah, it's gonna be fun. Okay, you need to get this one and 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 this length. I'll put blanks in boxes. And this length and this length, and I'm not sure if you can get this length, maybe based on scale factor, maybe, because you might have similar. I think you're gonna have similar triangles and scale factors. You got this. What else do you need? This length, I think. This angle, 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 this angle. You know, these, which might be kind of obvious. I think you can get this length based on similar triangles. This angle, this angle, this angle, this angle, this angle. Yeah, it's gonna be fun. It's gonna be a fun exercise. We're actually gonna save for tomorrow. And we're gonna do something a little bit different. We're gonna skip ahead into the homework, and we're gonna say you can do these. Use Pythagoras. I forgot how to spell Pythagoras. I think it's an A. And a squared plus b squared equals c squared. C is hypotenuse. Now it says find the missing side in each right triangle. None of these are right triangles by labeling. That's just sloppy bookmaking. These should have been labeled like this.
Good morning, Logan.
It would have been a little more excusable if they said these are all right triangles. Now find the missing sides. But they don't even state that they are right triangles, and they didn't label them as right triangles. Even if they said these are all right triangles, how do we know which one's the right angle? Well, at this point, we can thumb our nose at the geometers of the ancient time days and say, listen, we don't need the mark. We can see with our eyeballs. Our eyeballs know which one's the 90. It's modern era. This is a computer-generated triangle. It's not a mystery. So go ahead, find those. And ancient geometers, I mean like ones from 2 decades ago. I mean, they, up until this very day, they are all uppity about their markings, even when it's obvious. Okay, and then you can jump into number 8, using the stuff you just learned today about moving angles around. Yes, very fun. And if you're really ambitious, you can go on to number 9. Okay, so get a head start on the homework, because it, I don't know, we're getting a head start on the homework. Bye.